Hello, welcome. Now we're in the activity one of this Raspberry Pi 4. So we're using a program of Hello World. This program often the first program for beginners when learning a new program language. Its simplicity allows new programmers to familiarize themselves with the syntaxes and structure of a language while providing immediate feedback. In this exercise, we will write a basic Hello World program using Python 3 on Raspberry Pi. This program will print the text Hello World to the screen, demonstrating how to use the print function in Python. By completing this task, you will gain fundamental understanding of how to write and execute Python code.
The first part is printing down hello world. Then we are defining the value of 3.14 for the pi. Then we are printing down that value. And then we are printing down the type of that value. In this case, is a float, as you can see in the shell. Hi everyone, so now we are on the next activity. This is the basic operation of arrays. So we're importing numpy as np. Then we are declaring the x for an array of the values 1, 2, and 3. And then we are printing down the x. So this is going to be visible on the shell once we run the program. Next, we are doing basically the same, but in this case it's an arrange. So are going to be values from 0 to 9. And we are printing down that. And all of that is named y. Then we have an a, and this case is an array, so it's going to have the values 1, 3, 6, and 9, and it's going to print it down. Next we have linspace, and this is quite interesting. We firstly need to put the b equal np dot linspace. So now the first place is going to be the start number. So in this case we are going to start with a 0. Then we have to put the end number. So of our array is going to be of 15 values. And the next part is the count number. So here we are just adding 4 numbers in the array. So once we print it down, you're going to see how it's working the linspace. It's quite interesting. And we're printing down the b, so you can visualize that on the shell. Next we have c equals a minus b, and it's going to print down that value as well. And finally we're gonna calculate the square of every element in an array, doing as simple as print down a times 2, and that's it. I'm going to run it. Run model. And there you go. The first one is the first array. So we're just gonna print down 1, 2, and 3. The next one is an array from 0 to 9. So there are 10 values. It's an arrange from 0 to 9. Next we have the linspace. No, my bad. Next we have an array that are going to have the values 1, 3, 6, and 9. Next we have the linspace, that is the B letter. So it's 0, 5, 10, and 15, because we choose to have only 4 numbers in the array, and it's starting on 0 and is ending on 15.
Well, now we are in the activity of linear algebra. So we have importing numpy as np. So we have 3 letters here. We have the A, B, and C. So basically the A is an NP array from 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have also the NP linear invert from A. Then we have the B. The B is an NP array from 3 to 1. And also we have the NP lin solve A and B. Then we have the C. This is an NP random. It will be run from 3 to 3. And finally we have an NP point dot from A and C. So I'm gonna run the program so you can see how it's displaying this in the shell. So first of all, we have the A. As you can see, we have the linear algebra of the array from A, that is going to be 1, 2, 3, 4, 5, 6, and 7, 8, 9. And also we have the NP link invert from A, and is this part over here, as you can see. Below that we have the NP array from 3 to 1 NP link solve the A and B. Below that we have the NP random, the run 3 and 3. And finally we have the NP point out from A and C. So that's all.
Everyone, so we are now in the visualize in the arrays as images. So we're importing matplotlib library as the last activity. We're importing numpy as well, and our array is x equal np dot array 0, 1, 2, 3, 4. Then we have 5, 6, 7, 8, and 9. It's a D type. We are putting equal np dot uint number 8, and then we have to write down plt dot imshowx. Then we are disabling axis and the grid because we don't need them, and we are just showing the figure. So this is the figure here, and we can change the color and other stuff, but this is working just fine. See you guys.
So in this case we have changed the color map to gray. As you can see in the figure 1, we have this palette of colors that is going from white to black. So it's a color map for gray, as you can see.
Hi guys, so this is the last one. So we are just changing the name for the CMap as accent, and we have a new color map. So here are the colors, and the first ones here are the gray, then it's going to red, blah blah, to green. See you. In this code we're using np random.rand to create a random three-dimensional array. We just need to pass to it the size of every dimension. In the preceding example, we are creating a three-dimensional matrix with a size of 3 times 3 times 3. Run in the preceding code and see the output for yourself. So here is the code, and we are disabling the axis and the grid because we don't need them, and we're importing, of course, matplotlib and numpy, and that's the X array. As you can see, we're using random and rand, and here is the figure number 1. So it's a random three-dimensional ND array. See you guys. Hi everyone, so now we are on the matplotlib library. So the way I install the matplotlib library is using sudo apt update on the terminal, on here on the terminal, and then I put the following sudo apt install python 3 matplotlib library. Here we are on the exercise. So firstly, what we need to do is to import matplotlib library .myplot as plt, and later we have to import numpy as np, and then we have the coding. So the first part, we have initialize the x that is equal to np dot array 1, 2, 3, 4, d type equal np dot uint 8. Then we have the y equals x by 2 plus 1, and later on we are just doing a graph. So plt dot plot x and y, then plt dot grid. This is to have a separation between the values from 1 to 4 and 2 to 16, as you can see on the graph. And then we have the plt show, just to show us the figure 1. And is there, as you can see. Now I'm going to show you the next activity, that is this one here. So I'm going to run it, run model. And basically we are just adding this line over here, is the orange one. So again, we just added between the grid and the show, we added all this here. So the name of the figure is graph, as you can see, the title is graph. We have an X label for X and an X label for Y. And that's everything. We have 2 lines in the graph.
Now let's get into the code. For that, we will need to install the GPO library. The latest version of the Raspberry Pi OS comes with the GPO library already installed. However, if it is not there, we can install it by running the following command. So as you can see, we have the command that is apt get install python 3 rpi gpo y. So in there we can see that it's already installed. Now let's jump to the code. So in the code we have the import rpi gpo as gpo from time import sleep, gpo set warnings false, gpo set more, gpo board, gpo point set up, 8 gpo out, initial gpo low. So the first 2 lines of the import required libraries. Set the warning false, disable all warnings, and set mode is used to set the pin addressing mode. There are 2 modes, the GPO board and the GPO BCM. In the GPO board mode, we refer to the pins by their physical location numbers. In the GPO BCM, we refer to the pins by their Broadcom SoC channel number. I prefer the GPO board mode because it is easier to remember the pins by the physical location number. And also the board mode because it is easy, and you can use the GPO pin as an input or output. In the preceding code, the first argument is the pin number, and the second argument is the mode, and the third one is the initial state of the pin output. It is used to send either high or low signals to the input sleep. It is imported from the time library and it produces a delay or given number for seconds. Run the preceding program to make the LEDs blink. In order to terminate the program, press Ctrl C on the keyboard. So we have this the protoboard with the LED, and as you can see, it's running the program, so we can see the LED turning on and off simultaneously. So now we're on the next LED programming. So now we're using this circuit with this diagram. So there are 2 LEDs and 2 resistors on the GPI out 8 and 10. So those are the connections, and this is the circuit connected. So those are the LEDs, and as you can see is switching between on and off of the 2 LEDs, and this is the code here. So as we can see here, we just need to connect the anode for an additional LED to the pin 10 through a 220 ohm resistor, and we are making both of the LEDs blink alternately with this code. So basically it's like the last one, but in this case, in the while true, we are just making both of them high and low and wait 1 second and then interchange them to the opposite. So in this case the 8 was in high in the first sleep, and in the second sleep is in low, and in the case of 10 it was on low and then it's high. So it's going to keep switching between high and low for both of the LEDs. Hello, now we are on another activity, programming LEDs. So as you can see, we are using import LED and import sleep. As always, we are using the pins 2, 3, 4, 17, 27, 22, 10, 9, and 11. and sleep time we are using 0.2, and we have a try and accept. As you can see, the try is while true for let in lets, let point on, sleep time, and let off, and accept is like an error. So we have turned off all the lets. Well, it's in accept. So now I'm gonna show you how it's working on the protoboard. So as you can see, it's doing a cool effect that is turning like a serpent, like a snake, I mean. It's going from the first LED to the last one. So that's everything for this video. I hope you enjoy it. See you. So we are now in the practice of the push button programming with the GPIO. So as you can see, it will be while true, it will be in high, but when I push the button, it will be low. So the button that we have assigned is the 7. So in the physical part, we're connecting that to the GPIO, and also we have the while true. In this case, if it's true, it will be high. In other case, in else, it will be low. So when I push the button, it will be low. So now I'm gonna show you what happens when I press. When I will run the program first. As you can see, it's high, high, high because I'm not pressing the button. But when I push the button in this circuit, as you can see, when I press the button, and suddenly appears low. So it's very simple and it's quite fun, as you can see. Hi guys, so now we are making a slight change from the last push button. So basically we're making inverse logic here. We're connecting in the push button. Instead of this black cable that was previously connected to GND, now it's connected to 3 volts. And in the code, we modified it to work as put down there. So now, if we didn't push, or we don't push, I mean the button, it's going to be low, 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 and when we push it, it's going to show high. So it's going to be inverse logic comparing it to the last one. So I'm going to run it, run model. So as you can see now it's showing low and I'm not pushing it. So whenever I push it, it's showing high. So that's everything. Thank you so much.